IP addresses are set to run out in early 2011. We have nearly used up the 8 billion IPv4 addresses which have been around since the early 80s. IPv6 is the version of the Internet Protocol which has been designed to succeed IPv4. IPv6 uses a 128-bit address compared with IPv4's 32 bits, providing a significantly larger address pool. But the two versions are not compatible with one another. Eventually, systems will need to migrate to IPv6. How seriously should businesses be taking this issue today? I spoke to Nigel Titley, the chairman of regional internet registry RIPE NCC.
Businesses need to take the risk of IPv4 run out very, very seriously, because it isn't a risk, it is an actual fact. It will happen sometime early next year, and from that point onwards, IPv4 addresses will be increasingly scarce, very difficult to get hold of, and they will start to become expensive. You will actually have to start to pay for them.
Matthew Finney, CTO of communications firm Interroute, believes that enterprises should maintain a watching brief at the moment.
And I think for enterprises, they're frankly the ones who should worry the least, because most of their exposure to this is always translated anyway. They go through a firewall, they NAT effectively their IPv4 public address to a private address space, which is how most of the users in a company will see IP addresses. So they're the ones who've got the least to worry about. I think by and large for enterprises, the best thing to do is to watch it and wait and see. The activity is mainly incumbent on those using the public internet. So it's the access providers and how they allocate addresses, content providers, i.e. how you get found. And it's a slow sort of migration between IPv4 and IPv6. In fact, you're going to see almost parallel universes, and the best thing an enterprise can do is sort of stay in touch, but don't panic and just see what happens, because the IPv6 world lacks some of the sort of security mechanisms that they would be very comfortable with within the IPv4 world. So from that perspective, the best thing to do is just wait and see.
But Nigel Titley advises organisations to go further now or risk finding themselves without addresses to allocate.
The benefits of investing early in IPv6 as opposed to holding out and hoping that IPv4 will do you for the foreseeable future is that sooner or later there will be IPv6 customers out there who will not be able to access your services. And if you don't transfer over to IPv6, if you don't get the experience now, then you will be behind your competitors who will be able to service those customers, as opposed to you who won't. The date of IPv4 run out is going to be early next year. Probably January is when the central pool of IPv4 addresses will run out. These are held by an organisation called IANA, and it's virtually a certainty that these will be allocated, the final address pools will be allocated in January. From then onwards, we estimate that there are about 6 months of address space left in the regional internet registries, of which RIPE NCC is one. After that, RIPE NCC will run out of address space, and there will be no more fresh, clean address space available in Europe. All that you will be able to do is transfer address space from other organisations, and prices are reckoned to be around about $5 per IP address. For a /16, that amounts to a substantial amount of money to actually purchase address space, and there's no guarantee, of course, it will be available.
With the proliferation of devices and an explosion in the use of smart meters, which appears set for an exponential rise, will even the IPv6 address range be enough? Or will we be back having the same debate in 5 years' time?
Yes, the thing about IPv6 and the amount of address space that it has is that it's absolutely enormous. To give an example, if every IPv4 address were the size of a droplet of water, then the entire IPv4 address space would be could be roughly contained inside a telephone box, about 2 cubic meters. The amount of address space in the IPv6 universe would roughly fill out a sphere the volume of the orbit of Mercury. So we've got an awful lot more address space. We can afford to hand out an awful lot more of it.
I guess the question is, if you're rolling out smart sensors or a bunch of tablet devices, for most enterprises, if they're rolling out tablet devices, they will again be using allocated IP addresses, so they'll use a public IP address. But for those folks, I don't see it being an issue. If you're talking about you're building a nuclear power plant and you've got 8 million sensors around it, then that's your IPv6 world. The issue for IPv6 versus IPv4 is those who are accessing content can go through some form of translation. There's a thing called NAT PT, and other things the IETF are looking at. It's really the content providers who need to run both worlds so you can be found by IPv4 so IPv6. So no, I don't think you should necessarily say no, everyone can't have an iPad because I don't know if I should choose IPv6 or 4. No, that's not the issue.
IPv4 addresses were allocated haphazardly, with the result that some organisations still have large blocks of unused addresses, whilst others are close to running out. Is there anything else that can be done to alleviate the problem before the inevitable migration to IPv6?
Well, the first thing is that there is a whole pile of addresses that were allocated many, many years ago to people who frankly don't need them or don't need that level of them. So they could be a sort of grand give back of address space, which I don't think it would solve the problem, but it would prolong it for a little bit longer. They could also, the authorities could start to say, well, we're going to prioritise who gets IPv4 over who gets IPv6. I think, you could argue just purely technically that the content provider's need is possibly greater than the access provider. The access provider could live in a world of IPv6, but I think it's possibly a little political, and especially with debates around net neutrality, possibly not the one that the sort of more neutral internet authorities want to step into. So I think there's many things that can be done, and I think one of the things that kind of should have been done, and hopefully will get more focus now, is that when we moved from a 16-bit AES number to a 32-bit AES number, that the big part of that discussion was how do I transition from one to the other? And for most of you didn't even realise that, one, we had the problem, two, we solved it, and three, it actually occurred. I think with IPv6, in hindsight, more could have been done to think about, rather than two parallel universes, saying, well, hang on, we need to sort of punch holes between the two of them. So a lot of work now will be focused down on how can I interwork between these two largely separate address spaces, but that is really how you can mitigate the issues. And I think by and large, a lot of this will happen kind of out of sight of most CIOs and IT managers.